radius of convergence for a power series, we use the ratio test. Okay. And if you remember, the ratio test means that you're going to take a limit of the n plus first term over the nth term, and if that thing comes out less than 1, you get convergence. So when you use the ratio test, and whatever I get, I have to force it to be less than 1, and that will tell me any limits I have on x. What x values will make this sum converge. All right, so I take the limit as n goes to infinity. In absolute value, I have to put the n plus first term divided by the nth term, but I don't want to write it down because it takes a lot of space. I'm going to do the flip and multiply right away. Right? So divided by the nth term is the same as multiplying by the reciprocal of the nth term. All right, so then we see what cancels. I have an x minus 3 to the n plus 1 over an x minus 3 to the n. Everything will cancel except for an x minus 3. Right? Like bases, subtract the exponents. N plus 1 minus n is 1. So this is the limit as n goes to infinity of an x minus 3 times an n over n plus 1. And x minus 3 doesn't change no matter what n does. But what happens to n over n plus 1 as n goes to infinity? It goes to 1. Yeah. The degrees are the same, numerator and denominator. So you just look at the ratio of the leading coefficients. 1 over 1 is 1. So this limit now, when I let n go to infinity, is just that. Because the x minus 3 doesn't go anywhere. It is not affected at all by n getting really big. But the n over the n plus 1 is just 1. So this is my limit as n goes to infinity. And to get convergence, this limit has to be less than 1. So as soon as you get rid of, once you take your limit and get rid of your n's, you have to force this to happen, force whatever you get to be less than 1. Sometimes it's less than 1 no matter what, and then you say your interval of convergence is negative infinity to infinity. But in this case, I have to make sure that for whatever x is, x minus 3 in absolute value has to be less than 1. So to solve that equation, what x's make that true? That means that x minus 3 has to be sandwiched between 1 and negative 1. And then you just add 3, all 3 pieces here, and you get x has to be between 4 and 2. Yeah, so if the interval of convergence, an interval is just a set of numbers on a number line, right? 2 to 4. It's centered at 3. That's the radius from the center to the end. So my radius of convergence is 1. So that's my radius of convergence. The interval of convergence is at least 2 to 4, but I have to check the 2 and the 4 separately. Okay, so my interval of convergence is at least 2 to 4, but I have to check 2 and 4. So I go back to my original formula, this guy, and replace the x with a 2 and see what we get. So I'm going to have negative 1 to the n over n. Does that guy converge or diverge? It's going to converge. It's the alternating harmonic series. Even powers of n will make that positive. Odd powers of n, it'll be negative. So this is negative 1 plus a half minus a third plus a fourth. Right? The terms are decreasing towards 0. The signs are alternating. So the alternating series test says this converges. Right? When I check x equals 2, yeah, I mean 4. Yep, so when I check x equals 4, I get the sum from n equals 1 to infinity of 4 minus 3, right? If you replace that x, if you replace this x here with a 4, you get 4 minus 1, which is positive 1. You get 1 over n, which is 1 plus a half plus a third plus. That's the harmonic series, which we know diverges. So my interval of convergence is 2 to 4, including the 2 and not the 4.